Let's begin Introduction to Propositional Logic and English Sentence Translation. So before we can really dive in to the connectives and syntax of propositional logic, we have to talk about what a statement is. So a statement is a declarative sentence that can be either true or false. True is 1 and false is 0. This ties very closely to Boolean logic. In philosophy courses, you may see something like T's and F's instead of 1s and 0s. I'll be defining T and F a little bit differently later, but for now, just keep true as 1 and false as 0 in mind. So some examples of statements would be something like milk is white. And this can be true or false. For the most part, it is true. But chocolate milk is brown, so that might not be white. Second example, the cardinality of the empty set is equal to 0. That is also true. So that is a statement. It can be true or false. And finally, humans are just fish with legs. Well, that's not true. We are not fish with legs. We're much more than that. So that's false. But the point isn't whether or not these statements are true or false, but rather that they are statements, which means that in propositional logic, we can express them. We cannot express things like questions. So for instance, questions cannot be true or false. Will you go to the store for me? True. Doesn't make any sense. The other things we can't call statements would be imperatives. So imperatives are not statements. What is an imperative? An imperative is a command like kick me or kick him. Those can't be true or false. So when we talk about propositional logic, we're dealing with statements which are true or false. So the syntax of propositional logic. Well, I use the word propositions here. Propositions and statements are very closely related. A statement is usually a very specific instance, while a proposition just captures the general idea of a statement. But for this course, that really doesn't matter at all. The distinction isn't important. If you're a philosophy of logic instructor or a student, then it might be a little bit important to distinguish between the two. But propositions or statements are going to be denoted with capital letters, so like P, Q, R. So for instance, P is I cheated and Q is I wrote an exam. So those are propositions. Lowercase letters P, Q, and R are just general propositions that don't have any specific meaning. And we'll be using these for proofs. So capital letters will have English translations, while lowercase letters will not. Now, with all of these different propositions, we can use connectives to change their meaning or combine their meanings together. So the first thing I want to say is that a statement or proposition on its own is a well-formed formula, also known as a WFF or a WOOF, which means that it is okay in our syntax. The second statement says that not P is a WOOF. So if P is a WOOF, then not P is a WOOF. And this not just means negation. So this little half of a box is just not. The second one says that P and Q is a WOOF. So if P is a WOOF and Q is a WOOF, then we can connect them together for P and WOOF, or P and Q as a WOOF. And this is also known as a caret. That is the and symbol, that is a caret. Third, P or Q is a WOOF. So this is P or Q. And sometimes you might just call it PVQ or P wedge Q. And finally, the fifth one, P arrow Q, or rather if P, then Q is a WOOF. So if we have a proposition, we can do not P, we can do P and Q, we can do P or Q, and then we can also do if P, then Q. And when we get to the truth tables video, we'll learn about the truth conditions of each of these and how the truth output changes depending on the truth value of the proposition. But for now, I just want to focus on translating these into English. So here is a key of propositions, and here is a well-formed formula. And I'm saying translate the well-formed formula into English. So I am just going to read this out. So R and P, arrow, Q and S. And this can be translated to, if R and P, then Q and S. So how can we translate this into English? Well, let's do the arrow in a color. So we have if, a bunch of stuff, then some more stuff. And let's do the first bit first. So this is and with the conjunction. So what is R? Well, R is if I write an exam, and then we have our connective and now we have P. So what is P? Well, P is I cheat. So if I write an exam and I cheat, then with the arrow, Q, so I will get caught. Then this and, which I'll just rewrite in orange, is also and. Then what is S? S is I will fail. So this well-formed formula, given the key above, translates into if I write an exam and I cheat, then I will get caught and I will fail. And we can kind of see the groupings here. So we can see that R and P are a group together and Q and S is a group together. So if R and P, then Q and S. And all I did was translate this well-formed formula into English given the keys above. Of course, if I changed what the keys meant, then of course the sentence would change as well. In fact, it's not important that our sentence makes any sense at all. So these keys just happen to make a sentence that made sense, but it doesn't have to make sense. So keep that in mind when doing some of the problems on your own, because it's not always the case that what you translate is going to make much sense at all. Now that we've done a well-formed formula into English, let's do English into a well-formed formula. So I have this sentence here. If James does not die, then Mary will not get any money and James' family will be happy. So the first thing I kind of want to do is look at all the connectives. So the first thing I see here is an if-then statement. So I'm going to rewrite this if and then in light blue, which means at some point we're going to need an arrow. If James does not die, oh, I see a not in here, so let me put that in red. Then Mary will not get any money. I see another not there. That is another connective. And, oh, there's an and, so let's do and in orange. James' family will be happy. So what I see here is I see an if-then statement with James does die with a not in there. So we're going to have not something. Then Mary will not get any money, so there's a not there. And then there's something else. So it looks like our translation is going to take this form. Now we just have to define our keys. So the first key would be James does die, or James dies. So we can call this P is equal to James dies. Now why can't we say P is equal to James does not die? Well, not is a connective. So when we translate or give a key for our propositions, we want them to be an affirmative or a positive statement. We want not to be a connective that attaches to an affirmative statement. So if P is James dies, then not P would be James does not die. So the next one then, the next proposition, Mary will get any money, would be another statement or proposition. We wouldn't include not in there. So let's call that Q. Mary will get money. And I know it says we'll get any money, but the way that not works in English is we kind of need, or it's attached to not. If we say Mary will get any money, that sounds weird in English, so we just kind of align it. So Mary will get money, so it'll be not Q. And finally, James' family will be happy. So we can call this R, define this as James' family will be happy. And then finally, we can stick this into our last slot, R. So if not P, then not Q and R. And when we just have one statement on its own, we can just remove the brackets. So this says, if it is not the case that James dies, or if James does not die, then it is not the case that Mary will get money, and James' family will be happy. So hopefully with these examples, you kind of see how to take an English sentence and translate it back into a well-formed formula and vice versa. Of course, once you translate it into your formula, you should translate it back and just make sure that it says exactly what you want it to say. Of course, highlighting all the connectives in a sentence as well is very important. That can help you out. And of course, remember to always make sure that your statements are in the affirmative and then extract not afterwards. All right. Hopefully this helps. In the next video, we're going to take a look at truth tables and take a look at these connectives in a little bit more detail. So of course, it's very difficult to learn all the connectives straight away. So take some time, go through the video again, make up your own examples and try to translate them and just get a grasp of these connectives. When you get to truth tables, things make a little bit more sense.